will find the interactions between an ion and a neutral molecule, right? Neutral molecule means uncharged. It does not carry any net charge, right? So we have, suppose, a positive charge here, right? And we have a molecule. We have a positive charge and we have a molecule. So this charge will have a field around it. This will have a field around it. And there is a molecule which is here, right? So a molecule, I will say, if it is uncharged, it will be, there will be no polarization. It's not a polar molecule, right? I can say non-polar. Right? So, if we have a polar molecule, then the negative charge will be symmetrically distributed around the positive charge, like this. Under the action of this field, the negative side will be attracted to the left, and the positive side, we can say, will be repelled to the right. So it will be something like, something like this. So that will be the positive side, and that will be the negative side, right? And this will have a field like this, we can say. Right? Suppose this charge is of magnitude ZE. Right? So this E, I may call it EI, which will be called the induced field. The field of this charge induces a field in the molecule. And we will call this as the induced field. Right? And there will be, as a result, we can say that there will be a force on this charge because of this induced field. If we know the field due to a polar molecule, then this charge will interact with the field of the non-polar molecule. Now it is polarized now. Right? So we will say the force on the charge at some distance, let us say R, alright, that will be equal to ZE, the magnitude of the charge, and EI. Force is equal to QE. Right? R, this is equal to minus 2 alpha ZE whole square by 4 pi epsilon whole square into R to the power 5. EI is something like that. ZE in this and ZE is here, so that multiplied with this becomes ZE whole square, right? Okay, look the energy between the two, right? The electric field of the ion, the electric field of the ion here, if we have some electric field of the ion E, that will be equal to ZE over 4 pi epsilon R squared, epsilon and R square, and the field of this is that will be R cube. The Ri will be equal to R cube, right? We know that from the previous discussion, right? EI equal to, we can say, where EI equal to minus 2 induced polarization, right? Or induced dipole moment divided by 4 pi epsilon and R cube. That is the EI, right? And then when you put the value of mu induced in it here, then you get this thing. You know what I'm saying? Right? You get the value of this and the value of mu induced. So you get minus 2 alpha and ZE whole square. Right? Mu induced also you replace in this equation. Right? So the energy, interaction energy, right? The interaction energy W at R is equal to minus from infinity to that position R is force and the integral of force multiplied with the length increment dr. So if I put the value of Fr from equation 1 into equation 2, right? 1 in 2, so I see that is equal to, right, minus alpha ZE whole square divided by 2 and 4 pi epsilon whole square r to the power 4. Now, this thing, right? This thing is the electric field of a charged body, ZE over 4 pi epsilon r square. And that's literally minus alpha by 2 and ZE over 4 pi epsilon r and whole square. So that is equal to minus 1 over 2 alpha and to E square, where E is the charge of the ion. E is the electric field of the ion. In terms of electric field, what is this? That is polarizability of the molecule. This is polarizability of the molecule. And this is the electric field of the ion. So the direction energy depends upon the electric field of the ion, square of the electric field of the ion, and it is also directly proportional to the polarizability of the molecules. If the polarizability is greater, if it can be easily polarized, then the interaction energy will be larger. Right? Similarly, a dipole can also induce dipole moment in a neutral molecule. If we have a permanent dipole, right? Dipole, induced dipole interaction. Interactions mean the energy, right? The interaction energy between a permanent dipole and an induced dipole. Right? So, if we have, for example, these are also called Debye interactions. Right? If we have a permanent dipole, a permanent dipole, we have a permanent dipole with some angle theta. With some angle theta, with the line joining the permanent dipole and the dipole which is not permanent, which is induced. And let the induced has a polarizability of non-polar, right? Non-polar molecule, like something like this, or whatever. Not exactly the shape. Much can shape रखो दस जरूरी लगा से दस कर पारा देखो. Now, if there is a charge here, positive charge, then this will be the situation. But if there is a dipole moment, a molecule with permanent dipole, then it will not be like this. It will be little complicated. Right? Yes, sir. So then the interaction energy, the field, right, of the permanent dipole, the field of the permanent dipole, the field of this permanent dipole, that is the permanent dipole with dipole moment mu, right? That will be equal to mu into 1 plus 3. We know that cos square theta divided by, right, 4 pi epsilon r cubed. Is equal to this. This is the electric field of this. This is the electric field of this permanent. Now this electric field will cause polarization in the neutral molecule. This is the electric field, and this electric field varies as 1 over r cube of the dipole. This field will interact with the non-polar molecule and will induce some polarization in it. Right? So the interaction energy between this electric field and the induced dipole moment, right? That can be written as minus 1 over 2 alpha naught into a square. Like this. Right? We call it alpha naught because this is non-polar, right? R, that will be equal to, right, minus 1 over 2 alpha naught, and we write the electric field here. So that will be mu square 1 plus 3 cosine of theta whole square, alright, divided by mu square, right? And did I write alpha? Yes, there is an alpha and mu square, and this is 1 over 2, so this will become simple, right? And this will become r to the power, because this is r to the power 3. Let's square it, it will become r to the power 6. So look, the interaction energy here for in permanent dipole and an induced dipole. Permanent dipole, induced. That energy varies as 1 over r6. Right? और देखिए दबा हम देखते हैं ना 4 pi epsilon whole square होते हैं 4 pi epsilon square, right? Come here, Irfan, come here, just come here. Okay. So, if we consider these molecules are free to rotate, right? For free rotation are for a free molecule, right? If this molecule is free, it can rotate because of the thermal energy that is there. So we will take then the average of this dipole moment. Kala badasi, kala angle, ye kala angle bal. The rotation ki. Sahih though? Huh? The angle kala 20 kala 30 kala 40 kala. So we will take an average of this. This is the electric field. So this is fixed. All these things are constant, but the only thing is to take the average of the angle here, cos of the angle. When you take that, it comes out to be, right? Or we can say W of R equal to mu square alpha, right, and to 1 plus 3, and we take the average of cos square theta, right, divided by 2, 4 pi epsilon whole square r to the power 6. As for a free molecule. सही ना? और cos square theta चुनूंगा average हुआ that comes out to be equal to, when integrate theta, the solid angle one, right? Cos square theta, sin theta, d theta, d phi bane. You take what you do. You integrate the value of this particular quantity over the whole surface area, and then you divide by the total, which is 4 pi. Every that's it over a second. Jama ke total, ahare quantity sara, or vyapare total money divide. So that is how to take the average. Because for the 0 to pi or 0 to right? 0 to pi go after 0 to 2 pi go after. सही ना? और cos square theta चले गया वो तासो आगे वाले इंटीग्रेट के d theta और d phi का. Because तो बराशी सबसे बराशी तासो बराशी 1 over 3, which is the average. The average of cos square theta over one full rotation. Over one full rotation. So that will give you 1 over 3. Sorry? Nubya Vamunga Sarashi W of R will be equal to B square, right? Alpha naught divided by 2, 4 pi epsilon whole square. Say that? And r to the power 6, 1 over r to the power 6, and this will be 1 plus 1, which will be equal to 2. Okay? 1 over 3 will equal to
1, yes.
and 3, 1 over 3 is 1, and 1 plus 1 it gives you 2. So 2 goes with this 2, and you get what? Minus pakai dekha. Minus mu square alpha naught divided by 4 pi epsilon whole square r to the power. This is the interaction energy between a freely rotating molecule, which has a permanent dipole moment, and a neutral molecule, right, which has polarizability equal to alpha naught. So this intellectual energy varies as 1 over r to the power 6. And we know that the interaction energy of a permanent dipole, it varies as 1 over r to the power 3, right? Permanent dipole or energy dependence from the third,
Yes, sir.
right? Anyway, so generally is written a permanent molecule also has a induced dipole moment, induced polarization. Aga permanent silik na the permanent dipole, it also see some effect from the other dipole. Permanent was a permanent stuff. For permanent induced medium, which will change its net dipole moment. Right? Therefore, we can write equation number. One, two. So 2 can be written as 2 can be written as equation 2 can be written as W of R equal to minus مزيد وزي ما نقول 1 أو 2 دوار وليكو لك permanent today أغام polarized the equation we have to select generally that if they are permanent that was as well mu1 square alpha not 1 plus right. That is look alpha not 1 brother, alpha not 2 right? Dipole moment of the first and polarization of the second. Dipole moment of the first plus dipole moment plus dipole moment of the second if there are two, and polarization of the first. Alpha 0 1 right 4 pi after whole square power 6. Dispersion. This is very important. Dispersion and correction are dispersion forces. Dispersion and correction are dispersion forces. Say that? They are also called London forces. London forces. Right? And they are between induced dipoles and induced dipoles. When there is no permanent dipole. Force is between induced dipole and induced dipole. Right? Induced dipole and induced dipole. Induced dipole and say. So this is showing London. Right? These forces, some characteristic of these forces. Some characteristic of these forces. They are not between, they are non-electrostatic. Non-electro. There are no permanent dipoles and there are no charges. Therefore, these forces are non-electrostatic. They are called non-electrostatic, right? Keystone forces and divide forces, they are electrostatic in nature. But the dispersion forces, they are not. Because actually there are no ions involved. There are two neutral molecules here and two neutral molecules here. So they call it non-electrostatic forces. Right? Okay. They are also long range forces. Long range forces. Right? From 0.2 nanometer to 100 nanometers. Long range forces become maybe repulsive or attractive. Repulsive के लिए attractive के लिए. Maybe repulsive or attractive, depending upon the medium.
Video freeze. The video freely electric field. Electric field of the
Electric field is induced जो भी सही कहते ना. So they do not follow a simple power law. Simple power law from energy. If attractive, they can bring molecules together and can also align them. Some forces the yogata as the covalence or align covalence with respect to each other. Dispersion forces are non-additive. Non-additive. Non-additive, like an electrostatic force is not additively. Lambda however, if we have a charge here, and a charge here, right? Q1, Q2, Q3. Then we say the force on this is equal to the force of these two plus the force of Sada.
yes, sir.
We write this as Q1, Q2 over 4 pi epsilon and to R squared. And then we write Q1, Q3, right? And over 4 pi epsilon and R squared. These are additive. You add the effect between these two without considering this in the स्तर के पढ़ right? The effect between these two और दीवाने बिल्कुल स्तर की particular कदर चढ़ो भी नहीं. We have Jama plus The means की interaction or like other shadow exists की na.
Superposition. Penso.
Right? That's the meaning. So this is called forces additive in nature.
Additive.
But these forces, the dispersion forces, are not. The third charge actually disturbs the system. If there is a third charge, it changes the situation. So they are non-additive. No simple addition can be done.
You do not follow simple power laws. का
Yeah, simple power law से you know.
ऐसा मतलब है सब simple.
लगा कासल से लिखना, right? उससे the you can add them together and then like your power law हम actually that's it. 1 plus x to the power n is equal to 1 plus x to 1 plus x
NX.
plus x squared divided by 2 factorial plus x cubed by 3. 3 factorial is and so on. This is a power law. So if there are more of charges or more of dipoles, there are more dipoles, right? You cannot bring them into a simple formula like a power law. This is like binary situation, right? This power law explains things into the vicinity of a single point. So delta the single point to a party, that's the field यहाँ से the point of a example से हम लोग तरबिया सवारी जो खास point fix कर रहे हैं the party से the field संग change की delta बसंगीदा delta बसंगीदा delta बसंगीदा delta से पकारे delta से पकारे delta से पकारे. This is given by usually the power law. Like that's a McLaren series by Taylor series by Taylor series special y. Then what will be the value of x of the second point here? What will be the value of, for example, if you want to find a field, what will be the field here? What will be the field here? What will be the field here? The electrostatics they follow simple power law, right? To know the values of the quantity. What your quantity is that? How does it vary in the neighborhood of a point? Can be explained by this power law. Quantities which vary in the neighborhood of a certain point usually be explained by this, right? So they are complicated to be written as this like this. Not a simple power law. You cannot find the field outcome by these simple power laws. Right? What we have written here? The strength of those forces you cannot say it is r to the power 6 and r to the power 2 are quite complicated. The dispersion forces. Right? It will be clear as we move.
Osama laka the charges bare ki munga da sul kana chida repulsion de oda attractive. لك أصدق هو يديك هو charges من نشتا أو still يكمل دي repulsion or attractor like sense نرى دي سينجا لك repulsion ما سينجا يبيا
repulsion بداسي
لك charges كل نشتا كنا صار
charges كلش
जी
सही है charges نشتا تمام بيبرزي that's a force is repulsive depend upon the was double the repulsive equal attractive this depends upon the medium between the two dipoles and do it is that force is that's actually the answer the induced dipole or induced dipole say that
yes
the dispersion force is start with
yes
dispersion forces spreading of something in its components, right? Dispersion. So it will have a certain frequency. For example, last way, say that is a city, that is a you charge the move classically. Suppose say the electron पे your class लम्हा के दल पड़े जो dipole moment है दूसरा दल से जुड़ेगी negative और positive तरफ ठीक है ना दल तो your ball molecule है नदी बता कोशिश करी से दे दे पर favor की जोशी مثلا در منظور چه دست بشی depends upon the medium which is here. That's the medium input. Again, medium but in the attractive sheet or the repulsive sheet. They were the medium interaction in medium of that's an interaction.
yes
The medium नहीं नो ब्याह बसंगी ची medium भी नो ब्याह बसंगी के दिश medium पर टेन के दिल repulsive ची medium दर के नो attractive ची no that's the because that situation the pay of fast time की at a certain instant at a certain instant that situation suppose ذكر من بوينا دي of fast frequency now as a weak electron that gets up in the nucleus now. That we are discussing a classical situation, not quantum. It has a certain frequency around the nucleus. And we said that it has certain frequency. So at certain frequency, at certain time, you take the picture of it, it might be like this. And in this situation, it will induce here its effect. That's really instantaneously polarity, where the polar nature changing every instant, depending upon the frequency and its particular structure of the molecule. Назовем first density, но they better कोशिश कीजिए density जोड़ शी लगे हो किस्म का सारा, that's the negative ratio, है ना फर्स्ट का that's the positive rush, that's what we gave up. First it's a nishta, then the negative should be like this, suppose. That would be negative here. So that this negative can attract a positive and this can, but it's very complicated. So this instantaneous structure or shape determines what should be here. So the dipole moment comes from Pakala. Right? Who's the last one to somebody correct? That's how it comes. It's different situations. Could be like this should be attracting this, and this should be repulsing this, but this should also be attracting this. So it could be like this. So because of that, the two molecules may attract each other. They can rearrange each other in such a way should they give rise to an attractive force between them. They are not polar. They are polar molecules, but they do not have a permanent dipole.
Moment.
Yeah, they are not polar. They are neutral, right? They are not polar.
Induced.
Polar is like water, which has a permanent dipole moment.
Yes.
That is a polar molecule, right? It has a certain dipole moment. But these are not polar. They can be polarized if you apply a field to it.
Field.
Right? So these are called dispersion forces. Without any charge, there is no charge, everything is neutral. Things are neutral, no charges. Only by the motion, internal motion of the molecule, each molecule, here and here. This, we will think that the internal motion of this changes in such a way that either to attract that other or to repel that other, depending upon what is in between them. Very complicated. These are forces which we experimentally know, but we do not know what is the nature. So this is what this picture comes into our mind. Maybe after 100 years, people have different picture in mind. But these are what experimentally observed forces, and complicated, that you cannot put them in a clear formula, either electrostatic or whatever forces we know. They are very complicated. So they are called London forces or dispersion forces, which has a certain frequency. Dispersion depends upon the frequency. You put light through a prism and it changes it into components, right? We can say this disperses the spectrum of this, or this disperses the spectrum of this, and as a result,
Force there.
cause a force either repulsive or
Yeah.
attractive, depending upon what is in between them. Right?
Yes, sir.
Let us study this. This is a long topic. So let us do it in our next lecture. And these are the forces which are present everywhere. London forces are the forces which are present.
Everywhere.
Why?
Between molecules.
Why? Because they do not depend either positive charge or negative charge or whatever. They are there. Well, okay, electrostatic forces, if there are charges present, if there are no charges present, there will be no electricity. But these forces will be present, even if there are no charges. That's why the non-polar or inert gases they bond with each other. Inert gases के छे पोला बना भी कहते हैं helium छे वो सारा bonding के या the inert molecules जो वो सारा दिन छे तो temperature कमे आगे ना पे liquefy छे liquid helium तुम ना है liquid helium is a very useful liquid. So that it boiling point minus 76 Celsius पे आसर है
The argon gases मतलब the overall come the combine through dispersion force.
Exactly. Like a two temperature
They are
come
neutral. They are neutral.
Yes, two temperature come
Yes, sir.
the strength there come there. Dispersion force is ताकत there come there. which temperature कमे दूसरो शिबिया the forces ज़्यादा शिबिया अलग कारण से otherwise thermal energy दूसरा ज़्यादा तरह से that force बढ़ती. These forces, for example, in liquid helium, that has minus 76 Celsius something about that. I'm not I cannot say from the top of my head, but it's about that.
Yes.
At room temperature, they boil. They boil like a boiling water at room temperature. If you put it here, it will boil. خلق شو زيه لكن ضمن يخفي كده. I have done myself experiments for liquid helium, right? So helium is an inert gas. It's not positive, it's not negative, there are no charges. Still helium has a bond. And that found that gives rise to liquid shape.
So helium بس كذا كان فوز دا gases دي كان أول كم شيء دا كم دا نور دي نيان أرجان كريبتان دا liquid دا solid دي between molecules كم motion force دي
Gases دي كلام.
Yes.
حقيقة noble gases.